So we're going to conclude this section by doing an introduction into the Internet of Things, better known as IoT. So IoT is a broad buzzword, and it discusses, and specifically it describes, embedded computing and networking capabilities that are now embedded into everyday devices. And there are a variety of different IoT technologies, but one really popular one is home automation, like I have depicted here on the screen. And we're going to talk about some of the different protocols that relate to IoT. In other words, some of the more prominent IoT protocols such as Z-Wave, ANT+, Bluetooth, NFC, IR, RFID, and 802.11. And 802.11 is something that you should already know about because, well, that's what we've been discussing so far in this section. So I want to use our time here in this lecture to give you a high-level understanding of what these different technologies do. We're not going to get into the weeds and discuss specifically how all of them work, but instead I just want to give you a high-level understanding of what they do. So let's go ahead and let's get into it and start off our discussion talking about Z-Wave. So Z-Wave is probably an IoT protocol and technology that you're probably already using if you have some sort of home automation within your house, because, well, this is the most prominent protocol used for home automation. So devices like you see here on the screen, smart doorbells, smart locks, smart thermostats, smart lights, and so forth, anything related to home automation, it's typically going to be utilizing the Z-Wave protocol, which is a wireless protocol. So that's Z-Wave. So if you have any of these sort of things within your house, odds are is that it's utilizing the Z-Wave protocol. Moving on to ANT+. This is a wireless protocol, and it is designed to monitor sensor data that operates at the 2.4 gigahertz frequency band, and it's maintained by the ANT+ Alliance, but specifically this ANT+ Alliance, it's owned by Garmin. So you're going to see a lot of devices put out there by Garmin that utilize ANT+, but not only Garmin utilizes ANT+, but a lot of other companies that are related to health and fitness, they also utilize ANT+. So let's talk about some common ANT+ devices. Number one, heart rate monitors like we see right here. This is your typical chest heart rate monitor, and it utilizes the ANT+ protocol to communicate with a device such as your smartphone to tell you what your heart rate is. Number two, a blood pressure monitor like we see right here. And ANT+ is also very prominent in the cycling world. So when it comes to bicycles, specifically bicycling computers, bicycling power meters, and bicycling tire pressure monitors, like we see right here, this is going to be a tire pressure monitor for a bicycle, and this right here is going to be a computer combined with a power meter or potentially a cadence meter. These are going to be using ANT+. So that's the area in which ANT+ is prominent, mainly in the health and fitness area. So Bluetooth is an IoT protocol that we all use on a regular basis and we love. And we don't typically associate it with IoT, but it is associated with IoT. And it's a very popular wireless protocol for personal area networks, because if you think about it, when we're talking about Bluetooth, we're talking about things such as speakers and headsets, and it's communicating from one device to another via a personal area network. Now, like I said earlier in the course, Bluetooth does operate at the 2.4 gigahertz frequency band. So again, just like with ANT+, it may be an issue with 802.11. Now, in terms of short distance wireless communications, Bluetooth really is considered a market leader. And some examples that I have here on the screen, we have some Beats headphones, we have our Apple AirPods, we have a JBL Bluetooth speaker, and we have a Bluetooth headset with a speaker and a mic. Another common example of Bluetooth is also connecting our smartphone to our computer or connecting it to our car for hands-free calling. So when we're dealing with audio and speakers and headsets and mics, that's where Bluetooth is really popular. Moving on to the Near Field Communication Protocol, better known as NFC, this wireless protocol allows us to take two devices and to transfer information from one device to another over a very short distance of 4 centimeters or less, which is 1.6 inches or less. And this is very common in our tap-to-pay payment systems. So if you go to a store nowadays, not only with our smartphones like I have depicted down here, but also with our debit cards and our credit cards, we can tap to pay. And this is becoming very, very popular, especially in COVID, where people want to minimize contact with other people. With this, you can simply take your device or your credit card or debit card and get it within 4 centimeters of the payment system and utilize it that way without actually having to physically touch it. So that is NFC. Moving on to infrared or IR. This is a wireless protocol that's been around for decades. In fact, I don't even know how long it's been around, but it's been around for a very long time. What this does, just like its name implies, it utilizes infrared beams to send data transmission with a very limited range of approximately 30 feet or less, and it needs a direct line of sight. And it's very common in our TV controllers. So TV controllers typically are going to use infrared, and that's why you can only go so far from your TV, and if you go too far, your TV controller isn't going to work. It's also prominent in keyboards, but it's very prominent with thermometers, which a lot of us have had to deal with COVID. So you're going to see that infrared is very common in these three different scenarios. Moving on to radio frequency identification, better known as RFID. So how does RFID work and where is it commonly used? Well, RFID uses electromagnetic fields to automatically identify and track tags that are attached to objects. So what does that mean? Well, this is an example of RFID tags, and also in this card, there could potentially be an RFID tag as well, where we have information embedded in those tags, and we can use them for security purposes, and we can also use them for supply chain and inventory management purposes. So for example, let's talk about the purposes of supply chain management. Let's say that we're a large manufacturer and we're shipping $1 million shipment of equipment over to a large company such as Walmart. Well, we want to be able to track that from a supply chain perspective. Well, we can tag all of our boxes with RFID tags, and we can utilize freight shipping with a company like FedEx or UPS. And when we have that set up with a business account, we can track it from end to end via RFID tags from the source being us all the way to the destination where it's being delivered. Now, once it gets to the store, they can also use that for inventory management. So for example, let's take a really large big box store such as Costco or Walmart or Target, one of those large companies where they're going to have a really large store, and in the back, there's going to be a lot of inventory. RFID tags are also a very easy way to track our inventory, where we have RFID readers that are proximity readers where they read the information on something in the inventory as it goes out of the back stock room out onto the floor. Or we could have something like this where it's a handheld inventory reader as well. So it can be very valuable from an inventory management perspective as well. Now, let's lastly talk about door access cards. So like we see right here, we have a door access card for a person. And if you work at a company where you have to swipe your card to gain access into the building or to gain access to a certain part of the building, that's typically going to be utilizing RFID. They put some basic information into your RFID chip on your card, and the proximity reader is going to read that. And if you're supposed to have access, then it allows you in. If you don't, well, then it doesn't allow you in. So that's RFID. And then lastly, there's good old 802.11, which is what we've been talking about in this section in all the other lectures except for this one. So 802.11 is our stereotypical wireless Ethernet network for our computers and our devices that are network capable. Now, in terms of 802.11, it was traditionally used just for computers, but now it's also used for IoT devices. So what you're going to see here, for example, we have an Apple smartphone that is going to be utilizing 802.11 to connect to our wireless network. Now it's also very common to see 802.11 enabled parking meters. So in a metropolitan area where they may have a metropolitan area network set up with public Wi-Fi, well, they may have parking meters that connect via 802.11 to that larger wireless network. Now, additionally, things within our house that don't use Z-Wave, they're probably going to be utilizing either Bluetooth or 802.11. So a very good example would be a refrigerator. That's a smart refrigerator that connects to our wireless network. That's going to be connecting via 802.11, and things like the Amazon Echo that would be utilizing 802.11 as well. So anyways, that's our high-level introduction into IoT and the various different types of technologies within the IoT space. The whole purpose of this lecture was to give you a high-level understanding so you see where computer networking is going. We're going away from traditional computers to pretty much anything and everything that we can connect to some sort of a network to make it smart and to allow it to communicate with other devices. So hopefully this was beneficial and informational. If you have any questions, please let me know.